for the moment, I think we can turn our back to the standard particle and jump to the other side, which is relativity and gravity. So our listeners should know very well by this point that the standard model doesn't account for gravity. That's the crisis, quote unquote, in physics and people working on quantum gravity. But how does tinkering with gravity affect fine-tuning?
Yeah, well, of course, gravity plays such a central role in the universe, right? So it has shaped the universe since the initial moments, and we don't think about it necessarily as gravity, but the expansion of the universe is relativity in action, right? And so one of the things is we mentioned earlier on about the formation of the first elements, right? And that was during nucleosynthesis. That was tempered by the rate that the universe was expanding. So if you change the rate of expansion through nucleosynthesis, you change the outcome of nucleosynthesis. And I had a couple of students working on a few projects doing this, is that if you slow down expansion, then you can extend nucleosynthesis. And in fact, what's kind of fun, for a physicist's definition of the word fun, is that if you do that and you extend nucleosynthesis out, then what you can do is you can turn all of your atoms into iron, right? So instead of the universe having a big bang and then there being hydrogen and helium, which then go on to make stars, what you do is you delay nucleosynthesis. It keeps going. So hydrogen into helium into beryllium into et cetera, until you get to iron. So if you imagine that the universe had been born and we'd had this delayed nucleosynthesis, then it would have been filled with iron, and that iron could have fallen together to form iron stars, but iron stars don't burn, right? Iron, you can't use iron in nuclear reactions because it sucks in energy rather than releases energy. So you produce these huge balls of iron that would be hot because there's lots of gravity acting on them, but they would radiate away that heat and they would just become giant cold cannonballs in space. So again, in doing that, you've wiped out one of the key features for life in this universe, that we started with light elements, hydrogen and helium, that could be formed into stars, and then additional nuclear energy can be released because those elements are able to burn up into eventually iron themselves through the lives of stars. So it's one of those interesting things about why nucleosynthesis finished with just a couple of the lightest elements. And it's tied to, back to that question of why was there this particular ratio of matter to antimatter in the very early universe gets brought into this entire question again. So there's fine-tuning at all steps of the way. And again, if you take the wrong path, you rapidly find yourself in a universe that can't host life.